so. So as mentioned, I'm Brian Liverman. I'm one of the leaders or co-leaders of the Tableau user group for Northern Virginia. We call it Nova Tug. And Patrick was going to join us, but he had something come up last minute family-wise, so he's not able to get to us tonight. So you've got me for the moment, but I appreciate you being here. Appreciate you joining us. If you want to reach out to any of us, our email addresses are there. I can also drop mine into the chat as well, should that be something you want to reach out to get involved for everything. So today's agenda, just what we're doing now. So we're welcome and updates for you, myself, and if any other leaders were on here will be as well. We'll have Paul Albert speak to us for the presentation today, and then pretty much after that we're going to wrap up from there and call it a meeting. And this will probably be our last meeting for the year, and we'll start up again in 2022. I'm assuming in 2022 we'll look at doing some more over the web, via the web, online type things like this. And I'd like to get back to some in-person ones. We started this back in the beginning of 2020, and that's got one whole in-person meeting in the ropes or whatever done before everything kind of went crazy, and we just turned into these web ones. So certainly the web ones make it easier for everybody to participate at their will and as they need to, or more easily do so. So enough of me babbling. I don't know if anybody has any job opportunities that they'd like to present, or anybody that's looking for a job, feel free to speak up, or any other needs or news, feel free to unmute yourself and speak away now. I'll give you just a moment. All right, well, if anything comes up towards the end, I know we have a light crowd for today, but I apologize to Paul for that, but we'll get you going here and get you started, and we can always do this again if we need to. Had a good crowd say they accepted, so hopefully some will show up a little later on, but I don't want to take up everybody's time and just wait around for everyone. So as I mentioned, we're going to have Paul Albert. He's a Tableau instructor and adjunct lecturer at a couple different universities here in the Northern Virginia, DC area. He's got a presentation today on beyond pre-attentive attributes. So I will let Paul jump over and jump in, and let me see if I can remember how to stop presenting. And I'll have Paul get started on his presentation. And so let's see, let me stop sharing. There we go. And Paul, I will mute myself and let you present and get going. So thank you so much for joining us tonight.
Absolutely. Just stand by half a second. And I want to share this desktop. Now I want to share this. There we go. Great. No, thanks everyone for coming. My name is Paul Albert. I've retired from Tableau a few years ago. I was with Tableau supporting the sales team, and what I do now is offer workshops teaching Tableau to a number of local universities, and teaching the basics of visualization fundamentals as well as the basics of Tableau. Since retiring, I've also started doing graduate studies in art history as well as computational social sciences. There's something called the digital humanities, where what you're trying to do is use quantitative techniques to gain further insight into, in my case, either history or art. And that's sort of what I've been doing. So as someone who's started to do some studies in art history, what I wanted to do was talk a little bit about some of the things I've been learning and some of the things I've been thinking about in retrospect as a visualization practitioner, and really open a conversation with you. So I'm hoping we can make this a conversation. This is a pretty light group that we have here, which is great. Feel free to unmute yourself. Also feel free to raise your hand. If I don't see it, I'm bouncing across a couple screens, please unmute yourself and just speak up. I also have the chat window open, but easiest thing to do is unmute yourself. I'd love it if you guys get involved in the discussion that we're going to have. So let me share sort of like the basics of the last 4 years and give you a nutshell. 500 years of art history in one side. The way we basically trace art history, at least in the Western world, to Giorgio Vasari, who in 1550 published a book called Lives of Artists. And what his book really was about wasn't so much art. It wasn't about aesthetics. It wasn't about what made a good piece of art versus a bad piece of art. His book was solely a biography, a set of biographies of artists, or for the large part, a biography of artists. And for a major part of time, when people talk about art history, they were studying the lives of artists. They were studying sort of and trying to glean what made them so great. And in 1550 with Giorgio Vasari, the answer to what made an artist great was that they were given gifts by God. And the artist that he most favored was Michelangelo, and you see Michelangelo on the left. So it really focused on the idea of encoding, the creation of an artifact, and not so much how an artifact was created, how a visualization, how an image was created, but about who created it. Then art history shifted a focus to look at the object itself, the image itself. And this is part of the Sistine Chapel done by Michelangelo, so the representation. And you could get an art historian talking about how this marked a turning point in cultural history, where man was seen as somewhat of being an equal to God, or sharing this agency with God. You could find people who would talk about the use of physiology and the depiction of physiology and how this reflects an accurate understanding of anatomy. You would find people who would talk about sort of like the physical properties of the pigments that were used. And then the focus of art history moved from the object itself, the image, into the act of decoding and what it is that the viewer is processing. And it started out with the idea of the viewer's share. So the artist creates something, but the viewer is in dialogue with that something and creating what that meaning is. And recently, and I'm talking the last couple of decades, there's been an idea of forget the artist, forget the image, concentrate solely on the viewer. And of course, I'm talking with huge brushstrokes here, and forgive me if I'm not being exact, and keep in mind, I'm not a licensed trained art historian, but I do think it's really interesting, this shift to the viewer. So as somebody who comes from the Viz practitioner background, there's things about the way that people have dealt with art that's always fascinated me, or that I've really been fascinated with. For example, it wasn't always the case that art was contained on museum walls. It started out in private collections, in salons of usually fairly rich people, and they would find these unique ways to interact with their art. It wasn't uncommon at all for you to walk into a room and for all the artworks to be behind curtains. And then the person who's talking to you about the artworks would unveil each artwork as they were being discussed. It also wasn't uncommon for people to place their artworks so that they were a little bit in dialogue with each other. You might have a woman looking one way, and then if you followed her gaze, you would find another picture with the man looking back, or something like that. And it made me think a lot about dashboard design, and the interrelationship between images and drawing images, and also interacting with images. So that leads me to a question that I've been struggling with. Is data viz really data different from art? Certainly they're trying to do different things. It's a big question. They're trying to do something that might be a little bit different. One could argue that what data viz is doing is trying to, quote, show the data. But what it's trying to do is offer some sort of insight. It's trying to move the viewer. I'm talking about data viz and art right now, trying to move the viewer into realizing some sort of truth, or they're trying to get people to realize something. And in that way, they're fairly common. Certainly the picture on the right isn't trying to portray quantitative relationship, but you could also argue that the picture on the left, the chart on the left, William Playfair's 1786 first use of line charts, is trying to not necessarily just give you the numbers, but give a person an aha. And many viz practitioners talk about the difference between the looking at something because it's pretty and appreciating it because it's pretty, and the aha, getting something out of that. And I think those elements are there for both art and for data viz. And in our data viz community, we have, it's a big community, it's a big tent. We have people who are trying to push the envelope on what visualizations can do and almost creating data art. And, I don't know if I would necessarily call that a data viz. I think that what it's doing is going for aesthetic appreciation more than insight. And in the art world, something that went for aesthetic appreciation more than insight probably might be considered more decorative than art itself. And it's a lot of interplay. It gives me a lot. I've been thinking about this a lot, and it's a fun question to ask. So when we're talking about data visualization, what I want to do is look a little bit, take the spirit of how the art history world talks about reception theory, what's going on in the viewer's mind, and try to apply that to data visualization. When we talk about foundations, one of the common things that people talk about when they talk about visualization foundations is the idea of pre-attentive attributes. So these are ways that things can be visually coded, are visually interpreted. This is how information is processed by the mind almost immediately before it's sent to the attention processing units of our brain. If you don't mind, can you take a quick, find your chat feature, it's down in the bottom right. And if I can see from a few of you, have you seen this pre-attentive attributes, and have you heard it talk about pre-attentive attributes before? I'll take a second and sip while I hope you put something in the chat. Okay. Yeah, so it's a mix. We have some people who are new to this, including a person who teaches it. So we have the full gamut. A common way that people have used to demonstrate pre-attentive attributes when it comes to visualization is with a quick exercise. So this is from 2007. Stephen Few presented this exercise at IEEE Viz, InfoViz. And take a look at this. And the question is, how many different 5s are in this list of numbers? Now, think about the processing time and what the time it took you to do this, and I don't, not necessarily difficulty, but there is a lack of fluency. You're going through all these numbers, you're trying to isolate the fives, and then you're trying to count the fives. Now compare it with this. How many fives are in this list? And luckily there's five. So just by bolding the fives, we've been able to use pre-attentive attributes to make them stand out to the mind in order to process them more fluidly, in order to more easily see how many fives are in the list. So I've been to a number of different discussions on visualization foundations, and this exercise has almost become a meme where it's repeatedly done in different ways. It's different numbers, it's different lengths of lists. And I was kind of curious about where the meme started. So I wrote to Stephen Few. He thinks that it probably started with Colin Ware in the year 2000. And I think Stephen did a much better job encoding in bold his pre-attentive attributes than Colin does in making the red stand out in the exercise B below. Colin is looking for the number threes. I'm colorblind. Maybe the number threes stand out more to the other people on the call who aren't colorblind. But then I reached out to Colin and I said, well, where did this come from? And he wasn't sure. He thought he might have come up with it. But he says there's also a chance that I might have read it somewhere and it just persisted. I haven't pursued it any further. It was an intellectual itch that needed scratching. So this seems sound. I mean, this is foundational stuff. This is important stuff to understand that different ways of encoding things are interpreted more easily, are distinguishing things, are interpreted more easily to the mind. But I have a concern that the Viz community as a whole is placing a little bit too much emphasis on pre-attentive attributes. And it's not that they're wrong. It's just that there's a lot more going on with how people interpret a data viz than pre-attentive attributes. And the pre-attentive attributes, just focusing on that, kind of presents a model where you're thinking of the viz interpretation process of being mechanical. You know, if this is presented in exactly this way, it's going to be interpreted the same way by everyone else, by everyone who looks at it. And the problem is that people are much more messy. The way that people interpret things are much more messy. If you look at this chessboard, for example, a chess master could glance at it and tell you white's going to mate in 3. And they're not using pre-attentive attributes to pick up that pattern. What they've done is they've taught themselves to recognize different patterns within a chessboard, and they're over thousands of hours, you know, and they're recognizing those patterns and they're intuitively understanding what the situation is. So their interpretation of that chessboard isn't that mechanistic understanding, mechanistic representation of pre-attentive attributes. It's more than what the eye is perceiving. It's resting on a greater context of what's in the mind, what memories they have, probably other times that they face situations like this, and they're able to tell you much more quickly than I would about what the situation on the chessboard is. And that sort of intuitive white mates in 3 is exactly the type of intuitive understanding that we're hoping people who look at our visualizations get. And we're hoping to build visualizations that give people that access. Of course, we're not always doing our visualizations for experts, but The point I want to make is that there's a lot more going on in the mind when we look at an image and we try to make a judgment than pre-attentive attributes. So specifically, I've been pretty impressed by a model of cognition. So if we want to move beyond how does perception differ, or how can we code our visuals to make things more perceived than others, or things perceived differently than others, to how can we code our visualizations to make things interpreted better or more fluidly. There's a model of cognition that was developed by Daniel Kahneman, Amos Tversky. Daniel Kahneman won the Nobel Prize for this in economics, that talks about the idea of there being a system one and a system two way of thinking. And Daniel Kahneman has a great book called Fast and Slow Thinking. I recommend to anyone who's trying to do data visualization, where he talks about when things are perceived, there's this system one thinking that's fast, that's intuitive, but then it's going to be also interpreted by a system two way of thinking that is based on reasoning. It's slower, it's effortful. So this is, let me get my cursor where I need it. This is where we're talking about pre-attentive attributes resting. Here in just the stimulation. But the way that it's being interpreted also look like the chess master is also going to look at the past, it's going to look at memories, it's going to look at what's being learned. Now, looking at this model, does anyone have an idea, or does anyone have a thought on when somebody first approaches a data viz, what is going to guide their interpretation of the data viz? Is it going to be system one, or is it going to be system two? Or what do you think the first thing people look at when they start to look at a data visualization? Any thoughts? Unmute or put it in chat. Yeah, so we have one person who thinks system one, past experience. Let me do a little bit more of an experiment and lead to what I think that people really focus on heavily when they look at it at a data visualization. So think to yourself, what is this visualization showing? Any ideas? You know, we see that it's a line chart. So we know from past experiences that when we've seen line charts, it usually involves time. There's no guarantee this involves time, but it would be reasonable to assume that it involves time. And that's not a pre-attentive attribute, but that's sort of like a learned practice or a learned convention that we know of. If we look at it a little bit further, we can see that there seems to be some repetition, or the pattern seems to be repeated a little bit. This is what's behind that data viz. So it's a flight data set, domestic flights inside the United States, 29 million records total. And what I'm doing is I'm building a pane for every year, a point for every month, sizing and coloring the lines by the average delay, the average departure delay for each flight. So knowing that, knowing now that we know all this information, how do you all think we should title this chart? Any suggestions? Either speak up or chat. How would you title this? Well, let me give you some titles. One possible title could just be very descriptive: number of flights and average departure delay. We could go a little further and sort of say air traffic volume is regularly seasonal. Most flights are in July and August. Least flights are in February. We could try to correlate the two things that we're seeing and saying flight volume and average departure delay are not completely correlated. And then, so those are all possible ways of titling it. So the question that looking at the system 1 and system 2, this model of cognition and thinking about what's most important to the Viz practitioner, I kind of think that the titles give more insight than the Viz itself. And certainly the Viz and the titles need to work together. But if you had to choose one versus the other, the Viz without the titles on the left, our potential titles on the right, except for the top one, all of those titles are giving us some information and give us more information than looking at the Viz itself. So my hypothesis, and speak up if anyone disagrees, that titles in the text often guide the decoding, the interpretation, more than pre-attentive attributes, more than anything else that's being done with the graphic almost. And I'm going to talk in big, broad brushstrokes, and just because that's how I talk. So I kind of think that a person will glance at a chart, and then their system 2 is going to sort of say, well, what is the title saying? And then their system 1 might kick in and say, well, is this important to me? And do I need to be concerned? But it's all starting with the title. So to go back to the art history class, think about going to art museums. The last time you were in an art museum, do you think more people spent more time looking at the labels on the wall and the text on the wall, or did they spend more time looking at the art itself? And I've got a lot of slides, and we're, we have someone who's looking at the art. I actually would have said looking at the title. One of the things I like to do when I'm at museums, in addition to looking at the art, is looking at the people looking at the art. And what you see is someone will scan a number of artworks on the wall, and then they'll gravitate, and then they focus on the title, and then they'll step back and they'll look at the art. And I think for myself, actually, I always spend a long time just looking at the art without looking at the title, without looking at who it's done, and then sort of read the interpretation, and then step back and spend a long time looking at the art, which drives my wife crazy. So she tends not to stick with me too often in art museums. But they've actually done some studies on this. And so the top chart text table is kind of the world I'm living in. Unfortunately, academia is as bad as business in their love for tables. And this is a study that was done at the Chicago Institute of Art for selected artworks, paintings. But when you look at it, a little less than half the people didn't read the labels at all. for these selected artworks. But more than half, the half that did read the labels, spent about 48% of their time reading the label versus looking at the art. You know, if you just take that as the total attention spent on the artwork, 48% of their time was spent at the label. So it's not exactly what I expected. I expected it to be a little bit more because I expect people to behave like me, but I'm probably 50-50 or 55. But it's really interesting looking at this correlation, you know, looking at how people look at art as well as how people look at data visualization. So let me give you a proposition that if you have a title that's purely descriptive, you open yourself to many ways of people interpreting it. And that could be good and that could be bad. Perhaps, you know, there's a lot of problems with the chart on the left. The categories aren't consistent between the flu ages and the COVID-19 ages. When you present just a descriptive title, you're inviting people more to explore the visualization versus an advocation, a title that advocates or a title that explains. But if you look on the right, Ann Coulter got it completely wrong, you know. So her conclusion, because things were just a little nebulous and the chart itself was a little confusing, or maybe she honestly wanted to mislead people that for people under 60, coronavirus is less dangerous. And I think that's a problem. We're always going to have the problem of people misinterpreting charts. When I teach data visualization, there's lots and lots of reasons that you have an exploratory chart where you want people to be able to click around and choose their own adventure. But for basic block and tackle charts where you're trying to help make a point or you're trying to support a point, I always try to teach students that make that title support the point you want to make. You know, a descriptive title just isn't going, just doesn't give you the oomph that you can get. So I wanted to show some more things with titles. And if you look at this chart on the left, there's going to be a chart on the right in a second. You get that, okay, people are disappointed by the tools that they use in decision making. But when you look at the chart itself, it doesn't say anything at all about that. That's not what the chart describes. But I think if we were to do a test and ask people, what is your takeaway from this chart? It's not going to be that spreadsheets are the most used tool. It's that people are disappointed in the tools that they're using. It's going to be the title itself. And I'm just shocked that Harvard Business Review is really producing charts that lead to this interpretational frustration. I put one of their pie charts from this report up on the right. If you notice, you're really not clear what that 40% is doing. Are they just making business decisions without data? Our analysis? You know, they leave it unclear, but they come out with titles that advocate a viewpoint, that more of an explanatory title than a descriptive title. In the best case for the students I teach who are not building exploratory dashboards, but are trying to use graphics to make arguments, again, I suggest more of an advocate, more of a title that advocates, or more of a title that explains the particular point of view that you're trying to suggest. So going back to the Kahneman, Tversky, fast and slow model, one of the things you note is that there's well, one of the things they note, I'm sorry, is that the way that people behave isn't just based upon the current situation, that people develop rules of thumbs that called heuristics that guide them in how they make judgments, that guide them in how they make intuitions. People also have cognitive biases that guide them in how they think. So the cognitive bias can be thought of as almost a knee-jerk reaction to being presented with a situation. And since we were just talking about text, Kahneman and Tversky are behavioral psychologists. These are the sort of text experiments that they delight in. So if you look at on the left and on the right, actually, if you look at both of these sets of two questions, if we were to create a graph that said expected number of deaths, it would be the same for program A, program B on both sides. You know, so these are really equivalent from an expected value point of view. If anyone thinks otherwise, unmute, let me know. But the interesting thing that they found is preferences. So people have a bias when you're talking about gains to seek risk. You know, they're more willing to be risk seeking when you're talking about gains, and people have a bias to be risk averse when you're talking about losses. So if you're developing a title that advocates, it would look like a title that says, this is how you can avoid a loss, has a little more oomph than a title that says, this is how you can gain a value, which both would have more oomph than purely a descriptive title. But the same way that biases work when we're reading them verbally, so we have these pathways that our mind has developed to interpret things and to choose things. We have pathways our mind has developed to interpret things. So let me ask a question of the group. Does anybody see anything wrong with these visualizations? And you can unmute or come on chat. So does anyone see a problem? Right. So we had someone talk about the axes. You know, the fact is that our y-axes aren't starting at 0. And let's look at I'm playing around trying to chase my mouse across screens here. There we go. Okay, let's look at another example where there's axes that don't start at 0. So the last two, the Fox News bar charts, are classic examples of why you should start a bar chart at 0. I chose this just to show that this problem occurs in a lot of other domains. But if we look at chart C on the bottom left, what that chart is telling our perception is that the poorest quintile, the guys in number 5, that bar is 13 times larger than the point for number quintile 1, the most wealthy. So it's kind of telling the mind the eye is perceiving this and saying, oh, there's a 13x difference, or could, not that the mind is interpreting as 13x, but it's a huge difference in size and area between quintile 1 and quintile 5. If we remove the y-axis, I'm sorry, if we start the y-axis at 0, we'd find that the difference is only 26%. So by not starting our y-axis at 0, we've overstated the area difference between bar 1 and bar 5 is about 50 times larger. So we've overstated the difference implied by the relative areas. I'm sorry, the difference implied by the relative areas is 50 times larger. So it's not that the data is not there. If we looked at that at y-axis, we're able to see, okay, quintile 1 is 23, quintile 5 is 30, but our mind that's guiding our interpretation of that chart, that system 1 is seeing these differences in area and giving a little bit different, a much different impression to the mind. And this problem gets even more compounded when you're not just talking about height, but you're also talking about the relative size. And specifically, we're looking at icons of women. So they, icons, female icons. So, the person who designed this chart started the height at 5, but the way that everything is scaled relatively gives our system 1 mind a much different perception of the relative magnitudes and sizes than we would get if we just looked at the y-axis. This went around on Twitter last year, and one of the comments was, as you can read, that if this were true, it would really not be good for Indian women. So this idea of relative area leading to misperceptions of magnitude, you can also find that in other chart types that have problems, like a chloroplast map, where the map on the left, the area that's red, isn't showing the percentage of people, it's not showing the percentage of electoral votes. What it's showing is the percentage of land. So if land actually voted, that would be what the vote would be. The chart on the right is trying to fix that up by doing a hex map where the states are then sized by the electoral votes and trying to correct that. So there's a big problem with chloroplast maps unless what you're trying to show in the map is land. Unless you move to other types of chart types. And this extends to other types of practices where relative areas frustrate insight. For both pie charts and bubble charts, the human mind just isn't good at looking at the relative proportion of a pie slice or a bubble and being able to compare it. So we're frustrating insight. We're not allowing insight to be done as quickly. I'm a huge fan of a paper from Stephen Few. It's on his a blog. It's on his website called Save the Pie Charts for Dessert, that methodically discusses a lot of the failings of the pie chart and the inability to judge relative lack of area is just one of them. Bubble charts, I've yet to see a really good use of a bubble charts. I've used bubble charts, but I use them kind of like an amuse-bouche. I put a visualization I ask someone to think really hard about, and then I put maybe a bubble chart that's not that important. It's more decorative, saying, okay, relax a little bit, here's a pretty picture. and then another graph where here, think really hard about that. So let me pause for a second and ask if there's any questions. Okay. So I do want to talk about another consideration when we're talking about area. And in this case, it's area in bar charts. So let's pretend you're a decision maker. This is a graph that's showing you the last 10 years of rainfall by region. Really quickly, look at the chart and try hitting chat and saying, what rainfall do you think is most likely for this year? Is it going to be point A or is it going to be point B? I'm hoping for some quick responses. Find your chat. What do you think is most likely? Okay, we've got a number who are suggesting point A, and that indeed is correct. Point A is closer to the average than point B. But when we do this test within, in the labs or with subjects, usually with Amazon Turk, it turns out that people systematically think things are more likely to fall within the bar than to fall outside the bar. And this is a great article. Georgie Newman has written some great research, both into visualizations and cultural studies. This is from the paper where what he was doing was testing what's more likely inside or outside, and he tested the bar going down and as well as the bar going up. And pretty much across the board, there was a strong belief that things were more likely to be within the bar. So we're not talking pre-attentive enclosure. What we're talking about is this idea that the bar almost reifies. It becomes what that average is. And people don't anticipate or don't, their mind doesn't tell them, hey, things are just as likely to fall outside of the average. So moving beyond area, what I also wanted to do was talk a little bit about how things are ordered, and how the mind processes the way things are ordered. I've been doing a lot of computer vision work and machine learning, and I was just fascinated to learn that the way that computer vision and most languages, computer languages, will describe pictures, the y-axis actually goes down. And this is an artifact from the early days of digital cameras. And when they developed digital cameras, they would talk about the 0 y-axis being at the top of the frame. But there's whole domains of research, of thought out there that are perfectly comfortable with the idea of a y-axis going down. It still strikes me as pretty strange, but again, it's a social convention. It's something that we've learned and that we need to understand. This is also, we need to sort of investigate the conventions that the people who are viewing our visits have learned. So here's a controversial visualization that does the same thing. Some people love it, some people hate it. Some people like the idea that because what we're doing is talking about gun deaths, having the line go down to show that things are being lost is good. Other people say people just aren't used to seeing the y-axis going down this way, so you're frustrating insight. One thing I hadn't thought about, but I think is a very intelligent comment or criticism, Alberto Cairo wrote about this and was talking about how the ground figure works, that people could look at the white at the bottom and think, okay, that's the graph, because I'm so used to graphs going up like that. And if you think that the white is the graph that's being portrayed, it's actually showing gun deaths going down, not going up. So I don't want to say it's a bad visualization. When I first saw it, it really made me think. The unconventional portrayal of the y-axis made me take a look at it and probably spend more time on it than I would have spent if the y-axis was going in another direction. But for sure, it does change the processing fluency. So this is another example of relative order, and this was on the Georgia Department of Health website for a total of 1 day before it was taken down because it was so heavily criticized. One of the big problems is if we take a look at the y-axis, we notice that it's not chronological. So whatever sorting algorithm the person used to lay out the x-axis, disturb the order of the dates. And I'm pointing that out to say it makes a lot of sense to have your dates go chronologically, but that's kind of a social convention. That's something that we've learned as we've consumed these charts. And it certainly makes a lot of sense unless your dates are somehow completely discrete items that don't need to be ordered. In this case, it's easy to argue that they do need to be ordered. And this is a remake of that visualization, where not only did they change the order of the dates to have them done correctly, Alberto Cairo did this as well, but the way that they then grouped the bar. And if you look at the difference in how these are interpreted, I would argue that what the chart on the right is doing is playing to our order bias, that we want to see things in order, we want to see things grouped a different way. Yeah. When we're talking about order, usually in data visualization fundamentals, there's a common practice. We talk about dashboards, that what people pay most attention to is things on the top first and then left to right. And when you read a chart, you're reading left to right, at least in English-speaking countries. And I've just become obsessed with the practice of the economist to put the y-axes on the right. And I think it really makes a chart a lot more interpretable, that we're not stopping at, we're not starting at a y-axis, we're starting at the data, the graph, and then we're able to look at the y-axis on the right. I think you're able to read these a lot more fluidly. And I'm so taken by this that I predicted that Tableau, within the matter of months, is going to wake up to the beauty of this idea of putting the y-axis on the right and make it a check mark option in the edit axes field. And much to my chagrin, in preparing this presentation, I took another look at the first line graph ever done, William Playfair, and figured out, oh, wait a second. In 1786, the exemplar, the first line chart ever created, put the y-axis on the right. So I don't know if, one step forward, one step back. Certainly we're a lot more for it, but I'm chagrined to find out that this idea has been around so long and isn't widely adopted. So another point, talking about learning. So I don't think the industry has learned from these sort of examples going back to 1786. I think it's important to realize that visual interpretation can be partially learned. So when we're looking at things, we're also looking for patterns that we know are patterns that we've seen, and we're able to apply that to the insight we get. And I didn't know exactly how to bring this into the presentation because I think this is an important principle that's outside of pre-attentive attributes. But I didn't have a great place to put it, so I put it here. I put it here for a couple reasons. This is an idea called subitizing. And what researchers would do would quickly show a number of dots to people and ask them to report how many dots did we show you and how confident are you with the number of dots that were shown. And what they found is there was just this huge drop off between showing someone 6 things and then showing someone more things in terms of their confidence. And I think this might be kind of a clue on good ways of visualizing data is, you know, if you can do it, try to get to 6 categories that you're comparing. But I also love this because it's a great example of data visualization before the machine age, before the computer age. So there was a draftsman who figured out the logarithmic chart here and presented that and gave us the nice little curves to fit this in. But if you look at the chart on the right, what it's comparing is after they do a number of trials. So in the first trial, it took people a lot longer to count the larger numbers of circles than it did by the 10th trial. You know, so as they were exposing people to this experiment, the people became better. We learned, you know, we can shape our intuition. And that makes me wonder if maybe these sort of visits can be meaningful to the right sort of people, or to people who have learned enough to take a look at it. The viz on the left is comparing characteristics of TV screens. And I would love to be able to look at them and say, well, which screen is going to give me a better picture? The screen on the right is a network diagram. Oftentimes, these are shown just to show how complicated a problem is. But I would love it if they're being shown to also give information about the network itself, to give insights, rather than an emotive feeling, oh, this is such a complicated thing we're examining, to give more of a insight, oh, this is shaped this way. And I've been doing network science now for 2-3 years. I still can't look at that and say, well, this is an insight that can be gained from this. Other than that, you have a lot of things that are connected a lot of different ways. So let me put the pieces together. If you remember, we started with this slide, this exercise where we're trying to count the number of 5s. As I mentioned, it's become a bit of a meme. Everyone's doing this. This is from a Tableau for Teaching slide deck that Tableau produced. Jeffrey Schaefer wrote it. Tremendous respect for all the work that he's done. And this time, what he's looking for is the number of 7. And you see we have a lot more numbers that we're asking people to look through. He applies pre-attentive attributes to them. But then he finishes with a graph. So now we're stepping outside of pre-attentive attributes. And we've got a graph that gives us a title. number of times the digit 7 appears is 17. And then we have a bar chart that's ordered by the order of the numbers. And then he gives us a second chart where we have our bars that are ordered by the frequency. And in this case, the 7 is both the 7th in the chart if you order by number, and it's 7th in the chart if you order by frequency. But these sort of practices, the relative order of things, the relative shading of things, give us can help us give the viewers of our visualizations some additional insight. So I was at a conference earlier this year and saw another variation of the exercise, and luckily I have some time, so I'll share it with you. So this is the exact exercise that was used. Take a second, scan this, and try to see how many of the words describe a food. Now, think about the intellectual effort that was required from that. Let me ask this question one more time. How many of these pictures show a food? I think it's great. You know, I fell out of my chair when they showed this, just because I've seen the find the number of numbers exercise so often. I've seen it maybe 20, 30 times. So I've seen it a lot. Okay, so let me give you, let's wrap up. Let me go to my conclusion. That as Viz practitioners, we always need to ask, how is the Viz going to be interpreted? And pre-attentive attributes play a part, but there's a lot more going on that we need to be aware of. And, you know, certainly the practice of sharing your visualization and asking people, what are you getting out of this? What insights are you getting out of it is a good way to go. But there's so much more for us as a practice to learn and to research and to really understanding what is going on when people are looking at visualizations. So I salute you all. What you're doing is tremendously important. What you're doing is, with your data visualization practice, is helping people understand where they should put their attention. And somehow or another, I seem to have made this in time. So let me just stop and open up for questions.
I think your statement about how is the Viz going to be interpreted, and basically looking beyond how and looking at how people are going to kind of recognize things. That's a key takeaway that I have from that, because I know I'll build a presentation and think, oh, it makes perfect sense to me, but someone else looking at it from outside the group might not get it right away, and I have to explain it to them. So definitely thinking beyond those pre-attentive attributes is key. I definitely take that as a takeaway.
Great. Yeah. Okay. Well, I'm here for other questions. I'm able to pass this over to you, Brian.
Yeah, thank you very much. I appreciate you being with us here tonight, Paul. And I always enjoy getting different perspectives and hearing from other people. And it slowly helps my little brain pick up things and go along and hopefully become a better data visual guy. So I appreciate you presenting to us, and thought it was very entertaining. We have recorded this, and I will post it out to our LinkedIn page so that folks can see that at their leisure. And if they'd like to take a look at it again, it's available to them.